Hello, everybody. Welcome to another session, and we will continue our discussion of calculus. Just a quick recap as to what we were doing last time. We studied the concept of a limit. We wrote down a function in the following way, and we did things like this. I don't know if this is familiar, and if people remember, if all of you remember what we were talking about. But this was the main concept that we were exploring. So here there are three things, as you might recollect. One is this portion over here, the other is this portion over here, and then it's this one. So there is a function, and we talk about what happens to that function as the variable approaches a number of our choice. Okay, so it's a function. 1 over x is a function. You define it over all possible numbers except when x is equal to 0, because 1 over 0 is not defined. And then the function will move around in a different pace, right? As x increases, you will have the function value reduce. As x decreases, you'll have the function value increase. For example, 1 over 25 will be a lot smaller than 1 over 2. So what happens to this function as x approaches infinity? Now, I know all of us are very familiar with the concept of infinity, but the thing is, infinity is not a number. It's a symbol used to represent the concept of endlessness. It has a lot of different meanings in many different contexts. And to say that infinity is a number, or to say it is the largest number, all of that is not mathematically correct. Uh, I have a question in the chat which says, will this hold true if x is going to negative infinity as well? And that's also correct. But let us first formalize the definition of infinity, and then we will talk about negative infinity. A very good way to define infinity is that it's larger than any known or any number that you can come up with, and it's no particular natural number, it's not a particular real number, it's just a concept of being larger than anything else. Okay, so the fact that x approaches infinity, it means x will keep getting larger and larger and larger endlessly. It will never stop, it will never approach a particular number, nothing like it. It will just keep, you know, increasing. In that situation, 1 over x will go to 0. The other way to write this would be to say that 1 over x tends to 0 as x tends to infinity. Okay, so 1 over x tends to 0 as x tends to infinity implies that as x goes to infinity, 1 over x goes to 0. Now, the other way to write it is using the limit definition, and this is what we had established in our previous lectures. Something really cool happens over here. I could interchange 0 and infinity and it still makes sense. I could say limit x tends to 0, 1 over x equals infinity. So what it implies is that if x gets smaller and smaller and smaller, 1 over x gets larger and larger and larger. There are a lot more formal ways of defining this, and that comes under the topic of real analysis, which I hope to introduce to all of you maybe a few classes later. But at this point, we will stick with this definition. We also studied the concept of slope in a function, right? We defined the definition for slope. We said if this is a slide, we want to define what is the steepness of this slide, how inclined it is. By the way, on a side note, for any of you who is unfamiliar with all these lectures, you can just view the previous lectures on my YouTube channel, where I've titled them Calculus 1, Calculus 2, etc. And you can refresh your memory. We defined the concept of slope, and we said the definition would be, if this is your angle, then you call this B, you call this A, the slope will be B over A. That is the definition of slope. Okay, so naturally, if the angle gets larger and larger, you will have the slope also get larger in this particular situation. Let's say A is fixed and we keep increasing the size of the angle, and as it goes here, then you'll have a very, very steep slide because B is so much larger than A. Because B is increasing and A is decreasing when you increase the angle. All of this is fine. And for those of you who are comfortable with trigonometric notations, the slope is nothing but the tan of that particular angle, because tan is opposite over adjacent, sine over cos. So that's what we learned. And then we also came up with a formula which we defined to be the derivative of a function. I don't know how many of you recollect this, but a derivative of a function f of x was defined to be the following. It was f of x plus h minus f of x divided by h, and this whole thing limit as h tends to 0. This we said was our definition for the derivative of a function. I will not go through the entire grind of how we came up with this definition. You can check that video out. Does anybody remember that we had looked at this definition just before the Raising a Mathematician?
Yes, sir.
Okay, good. Anybody else remembers anything? Put it in the chat. Okay, good. I see that some people remember this equation, this formula. I think we have done an example problem, and we could do one more example problem now. Oh, we used delta instead of h. Thank you for that. Thank you for that comment. We had used delta. It was in April. Yes, it was long ago, 2 months ago. We used delta instead of h. That doesn't really matter, but I think we had a discussion, and then we said that having delta would be better. So x plus delta x minus f of x divided by delta x. Limit as delta x approaches 0. Now, the reason we say delta x is that is the change in x. This is how you define the slope at that given point. You pick the x, you pick a very small distance nearby, and you see what is the value of the function at that distance. Then you subtract the value at x, and then you divide it by the difference. So basically the same thing. Let me quickly draw that picture and remind all of you why that formula came about. So if this is your function, you want to find the slope at this point. What you say is this point is x. Okay, this is my y-axis, and let's say this point over here is x plus delta x, but delta x is a very small number. So we said we could actually have a small triangle over here, right? And we could calculate the slope over there. So what would be the height of that triangle? It would be this point minus this point, which is basically the f of x plus delta x over here. Then you subtract f of x, okay, and then you have to divide it by the base of the triangle. The base is nothing but x plus delta x minus x, which would be delta x.
And slope 1 in our
Do you guys remember that formula that we discussed? I could just magnify this triangle over here for you also. This is x, this is x plus delta x, and then sorry, this is f of x, I mean, because this is the base of the triangle over here. This is over here, you would have this distance to be delta x. Let me not write this x plus delta x. Let me make it simple, just a second. So we have that triangle over here. So right now here you have this function and something is going on over here. So this part over here, this part over here, and this part over here. So you want to calculate the slope. So the slope would be this thing, let's say b, divided by this thing, which is a. Now this distance over here would be this minus this, and this was f of x plus delta x. This is f of x. So you get b, and then you divide it by the base of the triangle. So what is the base of the triangle? It's just how far you went from x. That was x plus delta x. So then you subtract the two things, you'll get delta x. F of x plus delta x minus f of x. Sorry if there's too much material on the board at the moment, but I assume you're all familiar with this. We're doing the same thing. The way you calculate the slope is you do the height of the triangle and you divide it by the base. In this case, the height is basically the tip of the triangle minus wherever the base of the triangle is at. Right? That's the length of that height. So that would be f of x plus delta x. minus f of x. Then the base of the triangle is the perturbation, the distance, how much you went ahead. So if you started at x and you ended at x plus delta x, the distance is delta x. Okay, so let's quickly do an example problem. Let's see what is the slope of f of x equals x squared. This is a function, very easy to calculate the slope. So let's see what it would be. This would be f of x plus delta x minus f of x divided by delta x. This whole thing as delta x goes to 0, right? We want delta x to get smaller and smaller and smaller. Why do we want delta x to get smaller and smaller? Because in an ideal world, we want to calculate the slope at that point. And the way we estimate it is by calculating the slope slightly far away and slightly nearer, slightly nearer, slightly nearer, because you cannot ever divide by 0. You just estimate what happens to the limit as the point approaches the point that you started with. Okay, so this formula over here simplifies to the following. What is f of x plus delta x? F of x plus delta x would be x plus delta x the whole squared, because we are defining a function f of x equals x squared, right? So whatever the value is, it has to be squared to get the y value. This would be x squared plus 2 delta x plus delta x squared. Okay, now you have to subtract from it f of x minus x squared, and then you divide by delta x. So what do you get? X squared gets cancelled. Now you divide by delta x. Sorry. Yeah. Now when you divide by delta x, you are left with
it should be 2x times delta x.
2x times delta x. I'm sorry about that. So 2x times delta x, and then you will cancel out the delta x from there. You will be left with 2x plus you have this delta x over here when you divide delta x to both of them. So you're finally left with this equation over here, 2x plus delta x. But this whole formula is while limit delta x goes to 0. So what happens to this guy when delta x goes to 0? What happens to this whole equation when delta x goes to 0? 2x plus delta x, it becomes 2x, right? Because delta x is really small. It gets smaller and smaller and smaller. I will pause for a couple of minutes here and wait for any questions. If anybody is unclear as to why limit of 2x plus delta x when delta x goes to 0 is equal to 2x, let me know. Okay, what happens over here? Why is 2x plus delta x equal to 2x? Does anybody want to explain this? Do you want me to do the simplification process again? Let's do it. Okay, so we have this following function. Let's write it at the top. F of x equals x squared. This is our function. Very simple. So f of 2 will be 4, f of 5 will be 25, f of 1 will be 1, and so on. Now we want to find the derivative, that's the slope of this function, right? So let's give it a different notation, or let's not make this confusing. Let us say the formula is represented like this. Let us say this f dash of x is the slope of the function, and we write this as f of x plus delta x minus f of x divided by delta x. This was our formula, the one that I explained. Limit as delta x goes to 0. This is our formula which we wish to use on this guy. Are we clear so far? So we have a formula to calculate the slope. Okay, let's now forget about how we got the formula, what happened. Assuming all of us know that, let's now use the formula. We have a function f of x equals x squared. Now we want to use this formula on that function to get the slope of that function. Does that make sense? Basically, when I say slope of the function, it means you want to find the slope of that function at a given point, but then you can extend that definition to the whole function. But I want to pick a point on that function and I want to find out what is the slope. And right now, I don't know what that point is, so I'm saying it is f of x. I'm picking a point on this function and I want to know what is the slope. How does the graph of this function look like? So it looks something like this, right? It's the square function. It goes really quickly. You have 1 square is 1, then you have 2 squared is 4, 3 squared is 9. It grows really fast. But we want to know how fast it grows. What is the slope? And that is why we are doing this whole exercise. The whole point of calculus is to study the growth of functions and to understand what happens to them. Do they increase, decrease? So we have this formula. Now let us substitute the formula. What is f of x plus delta x minus f of x divided by delta x is our first question, right? So f of x plus delta x would be x plus delta x squared. Why is that? Because the function is going to square whatever you input into it. No matter what you give it. If you put x, it will give you x squared. If you put y, it will give you y squared. If you give it 3, it will give you 3 squared. So here we are inputting x plus delta x. So it will give you x plus delta x squared, right? And then what are we subtracting from that? We are subtracting f of x. And then to the whole thing, we are dividing by delta x. And we want to know the value of this formula when delta x goes to 0, right? So why are we doing the simplification? Because if I straight away substitute delta x to be equal to 0, this equation won't make any sense because I cannot divide anything by 0, right? It's not allowed. So my hope would be to simplify this to such a level that my delta x will not be in the denominator. Either it will be in the numerator as an addition, subtraction, multiplication. We are okay with any of that. We just don't want delta x to be in the denominator because we cannot divide by 0. So let us simplify. What is f of x plus delta x? That would be x plus delta x the whole square, right? What do we subtract from that? We subtract f of x, which is x square, and to the whole thing, we divide by delta x. So far, so good. That is why I sometimes prefer writing h, because delta x and x can get a little confusing when we simplify the bracket. But for our understanding at this stage, let us keep it delta x, but later we will switch to h as and when we need it. Right? So what is x plus delta x the whole squared? It's just a plus b the whole squared, the formula. So you have x squared plus 2x delta x plus delta x squared. This is f of x plus delta x squared. And from this, we are subtracting f of x, which is x squared. And to the whole thing, we are dividing by delta x. So now the x squared and x squared gets cancelled. So now you are left with the 2x delta x over delta x plus delta x square over delta x. I'm just splitting the fraction into 2 for simplification. So this becomes 2x plus delta x. So this is what we get when we simplify the formula to calculate the derivative of the function. Now let's apply the limit. So we have limit delta x tends to 0, 2x plus delta x. And now because delta x is not in the denominator, we are free to perform the substitution and we get 2x plus 0, which is 2x. Because right now we can quickly make delta x to be 0. It doesn't matter. It is limit delta x goes to 0. Yes, that's not the same as saying delta x equals 0, but we can do that because it doesn't change the formula in any way. The definition remains the same. If it was in the denominator, we would not be able to do that. It wouldn't make sense. Just think about it logically, right? So we have 2x plus delta x. Now we are saying delta x goes to 0. So what will happen to the whole thing? You have a number 2x, you're adding another number delta x. That other number is getting smaller and smaller and smaller and smaller and smaller. So you'll eventually be left with only 2x, right? You'll only be left with 2x, which is the answer. So now we can ultimately say that if f of x equals 2x, sorry, if f of x equals x squared, then f prime of x equals 2x. So we are defining that prime, f prime of x, to be the derivative of the function. Okay, does that make sense? Let's try a slightly simpler example. I know I'm going in the reverse direction. I should probably have showed you the simple example first. But the reason I wanted to show this one was to just give you a sense of how the simplification happens. Now let's go to a much simpler example. Let's deal with this function. Let's say f of x equals x. This is our function, lot simpler than the x squared function. And we wish to calculate the derivative, the slope of this function. Okay. Would anybody want to unmute their microphone and guide me as and when I do this simplification? Put it in the chat if you are interested to volunteer to explain what will happen step by step. We want to calculate the derivative of f of x equals x. Whatever I did for f of x equals x squared, we will do for f of x equals x, which is a lot simpler function. Would anybody like to volunteer? Okay, good. Somebody has raised their hand, and let's. So it's Panshul Chaudhary. Okay.
Yes.
Hello. So first tell me what is the formula to calculate the derivative. Let's just write it at the side so that everybody can see it. Let's write it over here.
Sir, it will be f of x plus delta x
Good.
minus f of x
Very good.
divided by delta x.
Okay.
Sir, we know that f of x.
Yeah, just a
will
sec.
give
Sorry to
us-
interrupt you. Just want to add that this whole thing limit when delta x goes to
tends
0.
to 0.
Okay, that's
Yes.
all. Okay, yeah, continue.
So we know that f of x will give us x.
Uh-huh.
So this equation we can write as x plus delta x minus x
Uh-huh.
divided by delta x.
Okay. So this becomes
X and x will get cancelled out, and delta x and delta x will also cancel out. So we will get 1.
good. Very good. So here the simplification is a lot simpler because we don't even need to substitute what the value of delta x is. I know that delta x is in the denominator over there in the last step before we get 1, but we aren't really worried about what delta x is. We are not even making it to be 0. We just know that there's a delta x in the numerator, there's delta x in the denominator. Both of them are going to 0 at the same speed. It doesn't matter who goes when. We can literally divide each other and you get 1. So even if delta x was any huge number, the answer would be the same, but it goes to 0. It so happens to go to 0, and we don't really care about it because when we finally apply the limit as delta x goes to 0, it doesn't even exist because finally I'm only left with 1, and I can say limit delta x goes to 0 of 1. It'll still stay 1 because delta x is not even there. And the meaning of this whole simplification is the fact that f of x equals x has slope 1. Let's check that with a diagram. So this is my graph. Let's draw f of x equals x. So we have f of 0 equals 0. Okay, f of, let's say this is 1, 2, 3, 4, 5. 1, 2, 3, and 4, let's say. So what is f of 1? Let me draw this in a better way. For some reason that is okay, good. Now f of 1 is 1, f of 2 is 2, and f of 3 is 3, right? F of x equals x, that's our formula, and f of minus 1 equals minus 1. So if I just draw this, this would be my function. And if I pick any point, what is the slope of this function? Let us see what's the slope over here. You do this, this is 1, this is 1. So the slope is 1. The slope of the function is 1. This is the definition of slope being 1. It's this horizontal slanting line where this angle is 45 degrees. Easy to check why it will be 45 degrees, because you have an isosceles triangle over here, right? Two sides are equal, so the angles also have to be equal at the base. It's isosceles right triangle. This is the definition of slope. So you notice one thing between the first simplification and this one. This is very interesting and something that I want all of you to remember. F prime of x, let's see. So we had the first function f of x equals x square. So over there we had our f prime of x to be 2x, right? That's what we simplified it. We got 2x as our final slope. And then we had our other function f of x equals x, and then we had f prime of x equals 1. So in the first function, our slope was 2x. The second function, our slope is 1. Well, the first thing that strikes me here is that in the first problem, even the slope has x in it eventually. The slope is 2x. The slope is not 2, it's 2x. But over here, the slope is 1. So that tells me that in the first function, the complicated function that we did, the slope depends on x. It will not stay the same for the whole function. It depends what x is, and then based on that, you'll get the slope at that point. So if x was 2, the slope would be 4 at that point. If x was 10, the slope would be 20 at that point. The slope changes based on x. That is why that graph looks like this. So as you go higher and higher up, the slope gets steeper and steeper because the slope is 2 times x. It depends on x. So if your x was like 10,000, the slope would be 20,000. The slope of 20,000 is almost like a completely straight line. So it gets steeper and steeper as x increases. Whereas in our second function, the slope is a solitary 1. It's not dependent on x at all. So no matter where you go in the function, the slope will always stay the same, and the slope is 1. So that tells us that this slope business, it need not stay the same for the whole function. It can also be a variable. It changes based on where you're looking at the slope. Incredible. The slope of the what is that? The first function, as x gets smaller and smaller and smaller, the slope also gets smaller and smaller and smaller. So I would like to give you something to think about. What if the slope of a function is also a function? That's exactly what we spoke about, right? It need not be a constant number. It could be a function that keeps changing depending on the value of x. Right? Think about it. And if you can fathom that thought, the next thing I would like you to think about, which I will not do today, but I just want you to think about it, is the idea that you could probably find the slope of a function, because the slope of a function itself is another function which keeps changing with x. So you could probably find the slope of that as well. Okay. That is the main topic that I wanted to talk about today. And I will give you a couple of problems to work on just to get practice of this formula. So let's try. The first thing is, let's do f of x equals 3x plus 5. Okay. Try to calculate the slope of this function. And the second problem is f of t. So this variable can change. Okay. This variable can change. It doesn't have to be x or whatever. That's just what you call it. I would like you to get used to using different variables. Let's say f of t equals 4t squared. These are the two problems that I would like you to try before we meet next time. And then we will see what goes on from there. So thank you so much, everybody. And I will now stop the recording.